Let's talk about array usage here. There's only a couple of ways you can use array for. One is using it as a data structure to manipulate data, right? The second thing is by passing in, right, into another function. So we frequently see this. So let's talk about just the standard usage here. As you can see here, in order to access a particular element, you have to index. You have to use the index that points to the specific location of the data. Indexing starts with 0. So array 0 gives you the very first element, right? Array 1 gives you, array is the name of this array right here. Array 2 gives you, right, this third element here. So index of first element is 0, right? Index of the last element is, right, n minus 1. So assuming n is the size. Or sometimes, you can dynamically, right, do the size of array. So size of array gives you the total size of the array, right? So if the array only has 3 elements, and this is, each of these is an integer, right? Integer is of 4 bytes, right? So the total number of memory that you have, number of bytes that you have is 4, right, times 3, because there are 3 elements, 12 bytes, okay? So literally this will give you 12 bytes, okay, 12 bytes, okay? Now, if you want to find out the number of elements, you can always do size of, right, the total number of bytes, right, divide by the size of, right? Remember, size of is a C function, array. So assuming array is not null, right, there's got to be at least 1 element in it, right? That's the premise. So you can always do array 0. So array 0 gives you the very first element, which is an integer. Size of the first integer is what? Is 4, right? So if you do this division right here, you should get 3. So this tells you, right, what is this? Number of, right, elements, right? Or the size of array, right? So that's how you do it, right? And in some languages, like in Java, array is actually an object. So literally, if array is an object, you can do array dot size, okay? Or you can do array dot length, something like that. And that, in fact, will give you the size of the array. But C++ is not. Array is simply a native a primitive type, a collection of them. So there is no class, right, object facilities here. So you have to manually do this calculation, size of calculation. One last thing about this is array usage. There's no such thing as a circular array, meaning when you get to n minus 1, which is the very last element, right, and assuming n is the size of the array, there is no way this will go back to 0, right? Meaning like array, right, goes around in circles, right? In fact, there's such thing that's called linked list, okay? Linked list. And in this case, we have circular linked list, but there is no such thing as circular array. So I just want to debunk the fact that lots of time people talk about circular thing, circular data structure. There's no circular array, right, as a data structure. Okay, so that's that. We often use loop to assign the array values. Yes, so if you can't do the initialization or uniform initialization like we talked about earlier, you would write a for loop. Yeah, so simply just by writing over 1,000 elements, right? Try to initialize it using curly braces is definitely not going to fly it. So you will want to use some sort of loop to accomplish it. But you can also, however, in some instances, you can declare something like this, right? And then said every single one of it needs to have a 0, initializing to a 0. So this is actually allowed in later version of C++. But that said, this is how we typically use array as a data structure. And another way of using array is by passing into another function to do something, right? Sometimes you don't want to pass in just one element, but in this case, you're passing the entire, right? The entire array into it. So the way that you do it is by declaring, right, initializing the array right here, and passing this in. So this ARR is an argument, right, for this function. Argument is what you pass into a function with. Parameter is what comes in as a function signature. So inside this function declarations here, actually function definitions here, A and length are both called parameters. But ARR is what we call arguments, right? So this sends arguments over into the function called sum. Okay, so that's one thing. And the other thing about this is that note what you really have. Let's just say A is here. Okay, so I don't know how many elements in there. Let's say this is A. Now, how would you pass in this entire thing? Would you be passing this entire thing as an object, right? Or would you need to zip it up or compress it or turn it into some sort of object and then kind of send it that way? No, you don't have to, okay? So in fact, every time you send this ARR, which represents integer array here, into a function, you are really sending, okay, the memory, okay, address of A0. Okay, this is curious. A0 is right here. Okay, so there is a memory address associated with it. I just say 0 times FA2. Okay, so at this location, at the very moment, every time you do a A0, which is the very first location of your first element, right, inside the array, it's got an address, and that address is actually the memory address of your A, right? We don't care about the second element's address, third, right? We care about the very first element of the address. So that address is what gets passed into it. Even though you're writing it this way, you're really passing in. If you output this thing, if you output this in C++, you can do cout A. What you're getting, right, is actually in this case, using the examples that we have, 0 times FA2, okay? And this will be the same also in C as well, right? In C, you use printf, and then you'll see this. So that's one way to kind of visualize it. And this is a good way to tee off what we call dynamic memory allocations. Let's take a look at some of the usage that we see here. As you can see, this A is being passed in. A is an array, right? So there's this physical bracket that you see here to indicate that this A is actually it's an array. And the other thing is the parameter is const. So const basically means read only. Yes, so you can pass this entire array in, ARR in there, into this function, and this function cannot write into it. This function can only read from it. So in other words, what you do here is you iterate through, right, the length of, whatever this is, and then you compute a sum of every single one of these elements, the summation of all of it, and return the sum. And doing a summation here, simply just read the value, right, at every given location. And notice that this is postfix, right? Postfix increment. So what this is saying is that you're iterating through every single one of these elements, and every time you're done creating, right, your summation, this is your binary, right, expression. Okay, binary assignment expression. But anyway, you're computing sum. This sum is the local that gets you the total summation of all of the values inside the array, and every iteration accounts for I++, right? So this is your control structure here. So that said, yeah, you're not writing into it. You're not changing the value of inside the A, but you're reading values from it to create the summation and return it at the end. So that's really it. You can definitely use array as a argument, right? And passing it into another function argument, passing it into another function. So this function argument is memory address. Specifically, what memory address? The memory address of the very first elements of the array. So I wanted to reinforce it because this is a good segue for us to talk about dynamic memory allocations next.